It was 18th December 2014. The LVM3 X-Care mission happened. So it was again a defining moment in my life. It was sort of a play on the thread. On either side, I can fall. A great bet I was taking for the launch. The LVM3 was approved in 2002 when we were working on the rocket for the last 14 years. The cryogenic stage and the engine required for the rocket was still not ready. Whereas the first stage of the rocket called the S200, the liquid stage called L110, were qualified sufficiently early, and we were almost 2 years since the qualification. And the rest of the engineering of the rocket was completed and hardware were ready, but we had no visibility of the cryogenic engine at the end. So it is another 2 more years. We had to wait for the launch to happen. So I proposed to the director at that time in ISRO, Dr. M.C. Dattan, and also the chairman, that time it was Dr. Radhakrishnan, that we should take a test flight of this rocket because it is very important for this rocket, looking very different from PSLV. It sits on challenges in aerodynamics and new propulsion systems. There is a transition from first stage S200 to E110 happening in the mid-flight, and there are control issues. So why don't we test this without the cryogenic stage and then prove the engineering of the rocket? Then it costs you money, and then who will give you this money? It was not there in the project report. Then I suggested, let us put the human spaceflight element called crew escape module, take it to some height and then drop and then test all the parachutes. You cannot test it otherwise without having a rocket to take it to that height. Nobody else can take it to 25 kilometers. So we devised a mission plan to do this using this rocket. Then submitted, there was huge objections in the organization system. Everybody said that never ever we did a test flight for any rocket. The very first flight of every rocket was full configuration, and we should actually wait and should not do this. Waste of money, things like that. And also, there were also objections saying that this rocket is not well designed. There are deficiencies, and it is likely to fail. And this happened for a few months, and I was under tremendous pressure as a project director to convince or otherwise. But more important was the government has to approve, and a new project approval for that money has to be given. It costed us almost 180 crores to do this mission. And who will give the money? It cannot be taken from the approved budget. Government project doesn't allow. That means you have to go to government approval, include a space mission, and get the sanction of this money. Then technically it has to be approved with the organization to convincingly proving that such a mission is possible. You also have to make ready the crew module with the parachute systems, recovery systems, and all the designs required for that human space flight within the short period of time and make the mission possible. I said, we are going to do it, but nobody believed. Then I remember the Dr. Nikishan, who later became the director of the Sarabhai Space Centre, was the director of the crew module project. And I asked the project director of LVM3, we decided that we will do this. But then what should be put in place of cryogenic stage? The cryogenic engine stage is not ready. So we decided that we put a dummy stage. The dummy stage will contain cryogenic liquid, like liquid nitrogen, but not the oxygen and hydrogen. So we don't have to fire the engine. So we made a dummy engine and put all the filling circuits, cryo arms, everything required for it. Tanks, everything looks alike, but the engine is not functional and the fuels were not like that fuels. But the rest of the rocket was just the same. And we made it, and there were a lot of reviews. And remember that a new rocket which is getting launched will always go through when there is reviews in the system. And this is a very beautiful part of ISRO. And you have to defend all the questions that are going to be asked. And I still remember the day an integrated technical review of this rocket was held in Vikram Sarabhai Space Centre. We made big volumes of documents, about 15 of them, describing every system in great detail. And there were a lot of questions, and I have to single-handedly answer most of those questions. I still remember, and people even talk about them. That days of answering, I think it's still etched in my memory. I still have a photograph of that, standing there and presenting that rocket. That was a 3-4 days of review continuously to convincingly prove that it is good rocket. But still, it was not the end of the clearance. There were still a lot of worries, residing worries that the rocket is still not having margins to fly. It is likely to fail. And somehow this message reached the chairman's ears, Dr. Radhakrishnan, and he was not very confident of launching because he was going to retire by December 2014. And just very close to his retirement, launching a new rocket and ending up with failure will not be in good light of his career. because he is definitely had a very good career as a chairman or a term as a chairman, because the earlier missions which the GSLV failed, they're all brought back to success. And many other successful launches and missions, including Chandrayaan, Mars orbiter mission, were accomplished in his time. So with that type of track record, if you want to retire, he doesn't want a bad track record to happen. Bad incident to happen before his retirement. And just 2 weeks before his retirement, the launch is scheduled. I remember still he took a review over the video meeting, and there were a lot of questions asked. And he, at the end of this, he declared that we are not going to clear this launch. Then by that night, I still remember he called me and fired me in such a way that I became crying. I remember the whole night I cried. I was a flight director. I just imagine the type of emotions that going through you. You put all your best efforts to make the rocket fly, and here is my boss not convincingly sure about this flight. I told him that I'll come and explain to you why this flight, it is not going to fail. So I called Dr. Suresh, BN Suresh, who was retired at that time. I think he was not director. And he said that I'll come with you. He also said, I'll come with you. We'll come to chairman. We'll explain to him why this should work. So we arranged a meeting at headquarters. I came with all the data and explained to them why there are margins, though it may not appear conventionally it has margin, but there are ways by which it has margin. So we were trending a path which was slightly different than what other rockets go. Here is what I still thank Sri Perumal. He is always unconventional. So I always try to be unconventional in doing things. So that always helps you to get over some worries, some situations. And it helped us in Chandrayaan 3 also. So when you look at very things not in the regular ways of solving problems, we will always find a solution. And this was very good in this. So Radhakrishnan was very magnanimous to accept this, though with no reluctantly, I don't know. Today he may not say that. But then he cleared the launch to happen. And with I still remember the day that launch happened, 18th December 2014. And another 12 days down the line, Dr. Adarsh is going to return. And the launch was such a great success. He took the care module to the 125 kilometer. All the stages worked beautifully. The control transition was very beautiful. There were no failures, no hardware failure or anything like that. It worked very well. Today, we proved the rocket that till all the launches till date were successful. There were no issues in the rocket. So I was very strong in trying to convince people that it's very important to collect data in real flight before we actually fly the cryogenic stage. The tagline was, before we give the cryogenic a chance, let us make sure the rocket is good. Otherwise, the failure happens before the cryogenic actually arrives. What is the point in sending cryogenic? So this was the tagline which actually helped to me to get through all those issues and clearances which were required in an organization. So after this, I believe that the human spaceflight program also got a fillip because of the crew module. We demonstrated the entire triple parachute opening sequence, everything. So it actually, the Human Spaceflight Center, the Human Spaceflight clearance, everything happened post this. But LVM3, there was another big journey yet to be completed. Development of cryogenic engine and the stage was still not completed. So I was the director of the rocket at that time. So Datan, who was the director of Vikram Sarabhai Space Centre, gave me more responsibilities at that time, and I became the associate director of the Vikram Sarabhai Space Centre. Meantime, I became the deputy director of propulsion entity, structures entity. Meantime, while I was holding the director post, I was handling many other multiple posts. Primarily, basically, I was getting trained in many other domains. I understand today to take up higher positions. You should definitely go through a tough journey in your life. Otherwise, why do you take a chairman position without going through that journey? You will get crumbled. So technically and managerially, you should equip yourself. And this was essentially part of our training, internal training. Those who have a likelihood of becoming leadership positions, we always ensure they go through a journey which gives some exposure into many areas, which includes technology, different technology, as well as administrative technologies. For example, in Vikram Sarabhai Space Centre, I was given responsibility for all the port band and review, which is a huge task. The conducting large-scale examinations, city question papers, conducting across the country entrance tests for many things. This was run for almost a year, which I had to do. And similarly, I had to handle domains which are unfamiliar to me, lead those domains. So this creates your capability to handle other centers, other organizations. Similarly, I was exposed to international exposure was very good for me. Ever since I had been spotted as a possible leader, it was made sure by previous chairman to send me to various forum. For example, UN Coopers, with I was sent, and then I was sent for International Strategic Federation meetings, and many international engagements and discussions for contracts and others. So I would have opportunity to visit many countries and spacefaring nations, test facilities in the last tens of years, and interact with leading people. Uh, Look at the global space issues and present at this appropriate forums. All of this become part of our learning process and internal process. This becomes a responsibility of the current leadership to prepare next generation of leadership. I will talk about this in my later part of this session, why it is important. And if you do not do that, you won't even find good people to lead the organization at some point in time. So I was very lucky to see that mentorship from my previous leadership, including directors and many others. So few of them I should mention is specifically Dr. Arshan has paid a lot of attention to it in developing next layers of leadership. Another is Dr. B.M. Suresh has mentored me he sent me to NASA once. I still remember one day he called and told that you just go book your ticket, you are going to NASA. So they are organizing a workshop there, you become part of it. So I went to NASA Kennedy Space Flight Center and spent almost a week with the NASA scientists to understand the space shuttle challenges and design issues. And I had the opportunity to go and watch the space shuttle in very close proximity and see its engineering. Same thing happened in Ariane 5 and 6. I had the opportunity to visit all the facilities and then see the rocket in very close proximity, which helped me to do engineering of our rockets much better. And so is the Russian, Ukrainian, and many other facilities which I visited, including test facilities. Of course, I had opportunity to visit SpaceX as well later. But though much later, that I didn't pay much contribution out of that to the programs. But then this exposure becomes important, technology, people, facility, and you need to see the scale, how it works. Then only you can actually replicate or do something. Otherwise, you won't even believe what is happening. So building leadership is important. So that was happening during those times. So by the time 2018 came, I was made the director of Liquid Propulsion Systems Centre, and Dr. Shivan moved to become the director of VSSC, and Kiran Kumar became the director of the chairman of ISRO. So those 3 years were a very interesting time in the IISc, where I had the task of developing two important things. One, cryogenic engine, which was still not completed. We had to complete all the qualification test programs, do a massive re-engineering of the engine, and then make it to go through testing and do the first flight of the engine. So I am very proud of the fact that after joining, I did the same thing. I put on a daily based effort to do the re-engineering of that. Every joint was modified to the requirement, the design, dynamic. All my domain knowledge was going into it. Along with the domain knowledge that existed in IISc, I don't say that it is me that told it. That is not proper to say. But then I have played a very important significant role in making it in the current state what it is. And I still tell that there were no single failures in the test program of the engine. And the successful D1 flight to the GSLV Mk III happened with that engine during the time when I was a director of LPSC. So that was a very important achievement. And Dr. Narayanan, who was the director of C25 at that time, was with me at that T. Then another important achievement was the Chandrayaan 2. Chandrayaan landing was a program which was running. Chandrayaan 2 was supposed to be launched. So we have developed a new engine, which is a throttleable engine, which will enable Chandrayaan 2 to land on the surface of moon. That was to be developed. So this development started, and I played very, very important role in configuring the engine, throttling mechanism, its circuits, test plans, testing that we did in many configurations. So that was very important development that happened and qualification that happened for Chandrayaan 2 launch. But that happened when I was in director of VSSC later, and Dr. Shivan became chairman of ISRO, and Chandrayaan 2 landing, and then of course the failure of not able to land happened. So these were two important developments. Of course, there were other many accomplishments that time, which includes large-scale facility building in LPSC that happened during that time. Which included production, which was becoming a bottleneck, where all over country, including large control component facilities set up, electric propulsion facilities were set up, new engine testing facility, and also our infrastructure improvement, expansion of the land. There's so many things happened in LPSC. Today, if you go to LPSC, you will see a different LPSC. And I'm very proud of the fact that significant expansion of the facilities happened during that time. Of course, with that help of Kiran Kumar, who was the chairman at that time, I could do that. Electric propulsion was specifically important. I remember electric propulsion was still not flown in any of satellites. So at that time, the Russians were helping us to get some thrusters, and electronics was being developed there. So first time we launched it with the Russian thruster on board one of the satellite with our electronics. And that electronics was a very challenging electronics, and I played a very important role in making sure that it work. So that is one contribution. Though I was not an electronics engineer, there were enough of other problems to make it work. But then the most important part is I got a new project approved to develop our own thruster and our own facility and our electronics with the 450 crore budget. And that facility is now currently up and running. And I'm sure today the whole development has been completed and is already integrated with the current one of the satellite now, a project which I started. So hopefully in another few months it will be launched. So the entire development completed, testing done. It's a 300 millinewton class thruster. It's one of the biggest electric thruster that was developed by ISRO to fly in one of the satellites. So that was again a good work. Another interesting work at that time is about the air breathing propulsion. And we did a launch of an air breathing engine. And LPSC had an important role to develop the fuel feed system, which was stagnant for many years. So I pushed along with the Rock Shivan. He was the director of VSSC. They were making the engine, but LPSC was making the fuel feed system. So now about LPSC is a very interesting story. LPSC started as part of the Vikram Sarabhai Space Centre. When Muthunayaga, who was the director of one of the stream, he was the chief of propulsion in ISRO, but he developed the industrial liquid stages and moved away from solid. And solid was handled by Rajaram Nagappa and many others, Uttam and many such people who many people may not know their names, but they are the veterans in our minds. So when Muthunayaga moved, he was later retired as the Secretary of the Government of India from the Ministry of Ocean Science and all that. So he started this new center as an auxiliary unit of propulsion. Later, it got the stature of a center and developed in Variamala. But its biggest facility came up in Mahendragiri, Tamil Nadu, as a testing facility. It's a very massive facility where we have set up testing for engines and stages, the integration of the facilities, which is currently serving ISRO. But when I became the director of the center, I was working in Variamala for many years. I never imagined I will become part of this center. I had no background on liquid propulsion when I became director of LPSC. This is something interesting. Without any background of liquid engineer stage, I became the propulsion center director. But then how will you manage the whole thing? So this is where your domain skills really come in. With your background in propulsion, of course, I had. But then specific engineering skills which are required to do that, they are not available. But then today I can be very proud that I had played a very important role in making the cryogenic engine, the throttle level engine, a large-scale control system, design modifications. So basically, if you keep your interest on, I think all these domains become available to you to solve problems. You don't need that type of and you don't have to know in advance. You need what you need in advance is basic physics. Then every awareness of how to handle problems and multiple domain awareness. So I told you about the knowledge I got from IISc that no problem is a real problem. You can actually solve any of them. So this type of confidence is what makes you drive to take up complex tasks. So LPS is really a wonderful organization. One of the most beautiful mechanical engineering domain that anyone can ever dream of is LPSC. I think many people are not fully exposed to it. There are not much of electronics happening there, but it's fully mechanical. Very precision manufacturing, precision dynamical systems, fluid and gas flow complexities. Such a beautiful engineering field for any true mechanical engineer to want to find joy in doing things I found there. And I always found morning onwards, I will go and stand in some of the labs where we do that type of design work and work with the people. It has always been an exciting journey. I never knew how those 3 years were spent. But by the time I was destined to become the director of Vikram Sarabhai Space Centre, Dr. Shivan moved to become the chairman. So it was a natural progression for considering seniority to take the VSSC. Of course, that is a place where I joined originally. So after so many years, I became the director of that center. But the next 3 years, when 3 or 4 years, when I was director of Vikram Sarabhai Space Centre during the tenure of Dr. Shivan as the chairman. It was not great event. No, I don't remember as a great event in there, except that we were doing a lot of launches. And Vikram Sarabhai Space Centre primarily responsible for all the rockets to be made ready and launched. But the interesting time is the COVID time. COVID was happening during that time as a director. And no launches were happening. Okay, so how do we launch during COVID time? So I came to Dr. Shivan and told that we will still launch. We don't need this many people to go to Sreedhara. We can send a small team of people in our own exclusivity to do the assembly there. Then we will control the rocket from Trivandrum. Don't have to go to Sreedhara. And we developed the whole system. Now we developed a remote launch complex at Sreedhara. Currently, launches are actually happening like that. Though you sit in Sreedhara, up to 20 minutes, entire operations are done from Trivandrum. And only at the end of 20 minutes, only the control is transferred to Sreedhara and move the control. So we established that and launched 2-3 launches during COVID time from there. So now Trivandrum has developed a very good control center. You must go and see that one day. They have developed it much bigger. Earlier it was small in a small room. We set up everything with the fiber network control extended from Chennai, Sreedhara up to Trivandrum with multiple links. And all the software is running in Trivandrum, checking this rocket, fitting at the launch pad from Trivandrum and then gearing it. So all that happened with the minimal people sitting at Sreedhara, we were able to do launch. So that was an interesting thing that we did during COVID time. Another interesting thing during COVID was review of R&D work. So every day I will sit in my home and then do a review. People sit at their home and on their computers connect, and then we used to take hundreds of different R&D projects we used to review every day. So that way we found COVID time was very usefully used in enhancing our R&D effort in the center and such very many topics. Now there are a lot of stories like that. But today I can tell you that VSSC was such a wonderful place. I think many people who do not know their center, you will find expertise in any domain you talk about. You will find people there. And very exciting place to work. When I was a young engineer, I never visited every place in VSSC because it's so vast and widespread, having facilities in so many domains. But then after becoming a center director, it was important for me to go around and understand different domains and then and work with the people. Working in software to hardware to propulsion to explosives to chemicals to adhesives, process engineering and whatnot. Anything you talk about is there. Of course, there are domains which are other centers of ISRO are handling. So many people who are listening to this may not know what ISRO is really. ISRO is such a vast organization. Vikram Sarabhai Space Centre is only one of the organized centers, but there are many other centers. I must tell you about centers like Bangalore, that we have Space Satellite Center, which is called UR Satellite Center today. All the satellite basic design and engineering is happening here. And here also in Bangalore, we have another center called LEOS, which is a small center, Laboratory for Electro-Optic Systems. And we also have another center called ISTRAC, ISRO Telemetry Tracking Center. These are 3 centers. We also have the Sreedhara Space Centre at Sreedhara, which does the launching of the rocket. But in addition to launching, they produce solid motors and also liquid fuel servicing, storage, all that they do. And also they do the control of the rocket and the ground stations management. The Space Application Center at Ahmedabad is a place where we build all the payloads of satellites, the cameras, the optics, the communication payloads, the scientific instruments, all are built at Space Application Center. They also develop applications based on this data that comes, the core of that applications are developed there and they are deployed across other application units spread across various parts of the country. We have another important center at Hyderabad called National Remote Sensing Center, which actually uses the satellite-based data to generate applications and launch it across user community. But there are other small centers, one at Trivandrum called ISRO Inertial Systems Centre, who manufacture the sensors, called gyros, accelerometers, and many actuators, solar panels, drives, so many things, gimballs, which are control actuators in the satellites and rockets. And we have 100% integrated capability today for all the rockets and satellites, and entire thing is manufactured within that facility. This is not even unimaginable for any other domains in India. I think during defense and missile, they still use imported components. There is many of them. But we don't use not even a single imported sensor in any of our rockets. So we have a Liquid Propulsion Systems Centre at Bengaluru, which does satellite propulsion. which is again a branch of LPSC at Trivandrum. The Mahendragiri facility is a big facility where we integrate and launch at liquid engine stages and prepare them for the rocket. We have facilities at Delhi, we have one at Dehradun, we have one at Assam, then Kanpur, Lucknow, Madhya Pradesh, and there are many such outreach centers for even in Rajasthan, in Jodhpur, where we have a National Remote Sensing Center outreach facility and user facility. So we spread across various country places to reach the benefits of the space to these people. So currently we have almost 16,000 on book, but I don't think that there are more than 14,500 people on ISRO's payrolls. It hardly around 8,000 engineers and scientists who handle the Polaris technology development program. And the biggest support comes from the industries. Actually, the manufacturing happens in industries, which was the area of not so. For forcing to manufacturing to assembly, there is a lot of partners, which actually has helped us to really scale it high. Now, let me go back in history of moving out to become the chairman of ISRO. So when Dr. Sivan was retiring in 2022-21 December, so I became the chairman of ISRO in 22 January till 24 December. I was the chairman of ISRO Secretary Department of Space. Dr. Sivan's time was very marked by a lot of ups and downs. Of course, you know that he was very successful in getting a lot of projects abroad, especially the PSLV continuation program, the GSLV continuation program, the human space flight program, the Aurora Cloud, and he also completed the Chandrayaan-2 mission, completed the manufacturing, design and launch of that, and many other missions that are accomplished during this time. But then there are two failures that happened during this time. One includes the GSLV launch. The last GSLV launched during this tenure had a failure. It did not reach the orbit, primarily due to a failure in the cryogenic stage. And then the Chandrayaan-2, though it reached the orbit, that could not soft land. So these were the challenges, and his challenges had to be overcome primarily. So these two failures had to be overcome. And then by the time there was an announcement of Space Sector opening up by government in 2020, that opening, the announcement happened. So Space Sector reforms was to happen, and implementation of this was becoming as a hot topic in the discussion between government and ISRO during that time. So these were the challenges which I had to overcome. One of GSLV. The GSLV failure was identified to be the problem in the cryogenic stage, and we addressed that problem and solved it forever. I can tell you that we found a very beautiful solution. This was a gas leak which was happening in one of the tanks, and we have solved a beautiful engineering problem. And this problem solution was extended to even LVM3 also. We found that this need to be extended to other rocket also. Today it is working beautifully. So there is one success story of that cryogenic engine problems. Next launch of GSLV was great success with the launch of NAVIC. The NVS-01 was launched with that GSLV. Another was Chandrayaan-2 to 3 transition. But here there had a lot of problems. For example, the failure analysis committee identified a lot of issues in the Chandrayaan-2 which had to be rectified, which includes issues in the guidance and many other marginalities, redundancy, lack of redundancy, and failure tolerance handling issues. So all were addressed, but the most important part was still not revealed. I must tell you that I was lucky enough to find out what really went wrong in Chandrayaan-2 was revealed to us by an interesting test, which was in the throttling of the engine. And this, once it was identified, I was sure that this mission is going to be great success. Again, but I did not want to rush through the launch. We waited almost 6 months further to ensure that the entire test campaign is completed, all the data is analyzed, all the required changes have been done, and support by people like Kiran Kumar, Koteshwar Rao, who are part of the earlier review for us, something phenomenal. They spend their day and night on this to help me to go through and understand so that necessary corrections can be done and the launch happen. But Chandrayaan-2 3 also showed another interesting story. I think all of you would have watched the Prime Minister Modi was there during Chandrayaan-2, and he couldn't see a soft landing. But when Chandrayaan-3 was scheduled, that on that day, Prime Minister was out of the country. And we said that we will go with the landing. And then the Prime Minister was ready to come on online on that day. And we were all very proud on that day that the whole landing happened, and it was watched live by 8 million plus people across the world on that day. Real time, live, which is a history in the watching of YouTube channels live. But more than that, it inspired a lot of school children. More than this 8 million, another interesting thing we did, I coordinated the government to make sure that this is live streamed in every schools and institutions in this country. And it was done immediately by the Education Department of the Government of India. And that's why the whole of the country, we had billboards and screens were put up on that day to show this. And see, we could have taken a view that anyway, Chandrayaan 2 was a failure. This 3 also could be a failure. It may show in a bad sense if it actually landed bad. This time our prestige will be lost. But I was very sure this time we are going to land perfectly. In fact, 1 month ahead of that landing, I went to IISc and gave a talk, which you can see that in the YouTube also, that this time we are going to make it successful because of such and such reasons. So I was very confident. And this confidence was reflected in everybody's work on that day, and we did it very well, landing perfect with no deviation, absolutely. None of the redundancy algorithms were even triggered, and we were landing at velocities far less than that we expected it to land. So it was such a benign landing. And not only landed perfectly, we also had the opportunity to bring the rover out and do all the experiments we faced. In the required time, we completed all of them, and also we did an additional test like hope test. At the last day, we jumped it up once again, which was unplanned. So we were, scheduled that software reloading on ground through simulations and demonstrated that it is possible to do that. So it was a good effort of Chandrayaan 3. But then, meantime, there were other things running here like Aditya L1, XPOSAT, SpaceX, NVSA Road2, and GSAT, IMSAT 3DS, and many of them were getting ready to launch. So pushing them to launch stages was a tough thing. And getting numbers launched. Meantime, we also want to take some commercial launches, like launches of the OneWeb satellite. The first time OneWeb came to us and requested that carry launches 36 satellites in one go. And we had no idea how to do that. But I went and met OneWeb team members, and I offered personally, I will do it. That's all. I don't know how to do it. I agreed to them that I will do it for this much of money. It was a commercial launch. And I came back and told my team members, I have given this word to them that we will launch it. I don't know how to do this. We have to find a solution to that. Nobody in the history has done using cryogenic stage multiple launches. It requires control systems, which requires precision orientation after every set of launch satellite to be launched. Do maneuvers of various types. And I don't have even fuel on board to do that. But we devised beautiful strategies and solved. I personally sat on the design of it, implemented all corrections, added new features on the cryogenic stage to make that happen, and flew without any test first time. Because it was all ground simulation, only mathematics, no actual test possible in the ground with the cryogenics. So that was successful, and we repeated it one more time. It was not a fluke to prove. We had 2 launches of OneWeb, and both brought us a lot of laurels and glory while we work on the LVM3. The first time in the history, using us left out hydrogen and oxygen into the stage. You control the stage without even firing the engine. Now use that gas and liquid as thrusters. We were able to do all the maneuvers perfectly. And all the physics that involved in the fluid movement, heating, evaporation, everything was mathematically modeled and captured. Because we are confident that you understand the physics, you can solve that problem mathematically. So engineering is always interesting because it is connected to mathematics is so strong. So that is a confidence you get out of. So I want to thank a lot of people, like me to understand that and solve that during that time. Now, this was the time Chandrayaan 3 happened, and we had a great jubilation everywhere. Of course, the government was also upbeat about this aspect. So I wanted to cash on this. Of course, the thing was happening that the space sector reform was happening, and space sector reform demanded that you must support private entrepreneurs without causing hardship to them, because private space ecosystem was coming up, and ISRO should empower them by making use that you give them technology, you give them facilities, you do not create bottlenecks in their thing. So there was a lot of worries that once you open up whether ISRO will lose a job. So I had to go around and speak to people saying that it is not the case. See, if you remain with ISRO, then our funding will be limited. You continue to remain only this much of money and this much of people. And what is the scale of our work? It's hardly 2-3 launches in a year. And our economy, as well as space sector is going to be concerned, will not grow. And if you have to really make it grow, we need to allow private people to start working in this. And it's important for us to enable this to transition to happen. Our knowledge is a public funded knowledge, and this must be become a part of the public knowledge. So this is the responsibility today we have, and it has to happen. And this was slowly understood today. And a lot of people are now having not much difficulty. Of course, there are bureaucratic hassle to go through, but private people are getting the required help, and you can see the growth happening in the recent times. So this is one of the important role. I brought out the policy, which has gone through a lot of drafting. The Space Policy 2023 came out during that time. We also drafted the Space Bill. Of course, it didn't get through. We enabled the in-space activation. There was only chairman available. Nobody else was there. The entire staffing was done. Entire work. The inauguration of the in-space happened. The facilities were allocated. Their report, their work has initiated during my time. Today, they are also working very well in terms of bringing out new programs for enabling private space ecosystem. So this is another important thing. Third, of course, government looked at and asked me that why don't you look at a vision for next 25 years, create a vision. Prime Minister himself directly asked me, so I prepared it, which included so many things. I want to tell you about this aspect. So next 25 years, it was a program of the government. By the time we celebrate our 100th years of independence, we must have significant progress in different sectors. And there are committees of secretaries meetings in Delhi, where space was also a component of various discussions. So defense and technology and many other domains were discussed. So I prepared this from my own discussing through a brainstorming session we conducted across center. We spent 2 days, all the top leadership of ISRO we assembled at one place for 2 days, and we did a brainstorming session on what we should do in each of the sectors. And we created a roadmap, how we should do that. And this was summarized into a few actionable, visible items. The visible items were that we must continue the Chandrayaan story. We should end with Chandrayaan 3. We should go continuously to go to moon. Thus came the definition of Chandrayaan 4 and 5. And we should do exploration missions like Aditya. I forgot to tell about Aditya L1 again. That's an interesting story. I come back to this a little later. But then like Aditya L1 and XPOSAT, which was for black hole studies, you should continue to do scientific missions, because if you purely on applications, the skill of our technology people will not develop, and you will not be helping that science domain in the country to grow, because unless ISRO become part of that growth, developing instruments and observation capability and data, science segment cannot grow. So we must collaboratively work with the science organizations to develop new programs. That's why the mission to Venus happened. We are looking at the future Mars landing mission, etc. So that side also should grow. But essentially, we suggested that we must send out human beings to moon and bring them back before 2047. An Indian landing on the moon and coming back becomes a higher goal. And to enable this, we must produce many capabilities along the path. The path is important, not the human landing on the moon is very important. The path enables us to do many things. One, enhance our launch capacity substantially. Today, we can launch only about 5 tons to GDO, maybe 10 tons to GDO. Just to go to 50, 60 tons to build a space station. So we came with the idea of NGLV, the new generation launch vehicle, where we have to increase the launch capacity substantially and also bring down the cost using reusability. So a rocket with that was designed. It took almost 1 year for me to complete the design review and submit the project report, and government has approved the project. 8,000 crores of money has been sanctioned already. The work has started. Another is we should build a space station to go to intermediary. Once human space flight is demonstrated, what is the next step? If you're simply sending a human to space and bringing back, it's not going to help us in any way. A human space flight is essentially important because you can keep human for a long time in space. And that is possible only if you have a space station. If it cannot, otherwise you have to send them to moon. So space station was ideated, and we defined how it is going to be. Today we have an approval for a Bharati Antarctica station. The first module has already been funded, but we'll be developing a 60-ton space station with the size, everything. And recently I sat through its design review. I completed the design of the space station architecture, which we have started building. Another is that we have to, that Chandrayaan series I told you, where 2 important science missions, Chandrayaan 4 and 5 are approved. Chandrayaan 4 is basically to go to moon and collect samples and come back. And Chandrayaan 5 is to use a rover and explore South Pole for long duration than that 14 days we did. So it is almost 100 days using nuclear-powered rovers. Here it's a collaborative mission with Japan and India. So we will achieve that using their rocket launch. So this also got approved. Venus mission got approved. So, but the most important approval was none of this. Most important approval was again launching another 50 more satellites. We got approval. Essentially, our total stock of satellites hardly 56 satellites. India has so far launched are only there. So in next 5 years, we will be launching additional 50 satellites. And this is Earth observation satellites. We got approval. And we also got approval for another 30 different technology and communication satellites meantime. So that means our resource satellites, INSAT series, NAVIC series, all of them got approval, and they're all in different stages of manufacturing and launching. Another important thing in the satellite thing is, instead of its government funding satellites, now it is funded by user. So we have a different funding model today. Ministries have to fund the satellite what they want to use. For example, if it is a weather satellite, IMD has to fund. And that's how we are funding the future satellites. So earlier the funding was to ISRO. Now it's no longer directly funded. The user gets the money from government, and the user gives the responsibility to do it. But that is because if private comes capable to do it on their own, they can give it to private also at some point in time. That's why this change is happening. So this is interesting. So there is a huge amount of satellite workload happening. Equally interesting is that we have handed over the technology of rockets to private. He announced his PSLV technology transfer that happened to HL Atlantic Consortia has taken over that technology transfer. This again is interesting work that we did. And another is that we gave manufacturing and launching a satellite only them to another industry consortia. 5 of the PSLVs were handed over to the right consortia to build and launch. So these two initiatives happened there. I forgot to tell you about the SSLV launch during my time as director of VSSC. That was again another development, primarily to design and develop a smaller rocket where industry can learn to build. It is less complex than PSLV or less complex than LVM3, but essentially we made SSLV less complex primarily to make sure that industry can absorb that very fast. So we made sure in 2 years of time they can learn the rocket technology and then upgrade themselves. But if we hand over PSLV or LVM3 to them, they will take enormous amount of time to learn and understand. So essentially, I give the design to make sure that it is very simple in its architecture and uses materials which are less exotic and approaches which are less exotic. So, and machining and manufacturing process which is very commonly available. So first time in the history, we have used a reverse approach that instead of using very advanced technology, use a moderately advanced technology to develop the rocket. But it enabled a good payload with a very low cost. You cannot even imagine the cost reduction coming out of this. So substantially low cost. And this rocket is now with the hands of the private players today. So I am very proud of that aspect, that we are enabling private companies to build rockets based on the knowledge that we have. I forgot to tell about Aditya L1 launch. Aditya L1 was another interesting mission, which has to go to Lagrangian point L1 and observe sun. And this mission was waiting for launch for the last 10 years when I took over as chairman. I realized where the issues are. Because it was a joint development. It is not by ISRO alone. It was developed by Institute of Astrophysics, IUCA, and many others. They are part of this journey. And many of the design issues were still getting floated. It is not getting concluded because when multiple teams start working, it is difficult to find a common ground on which we can agree and disagree. So this is where I have to play a role of very firm decision maker, that you have to be there or not there. No, we have to give ultimatums, you have to track them and make sure it comes on time. And that played well, and because of with the appropriate people who in the part of the role to play these roles. Of course, I am not doing it everyday basis, but then when there are appropriate people to do that, things happen. And this happened, and I requested the URSC to take full lead, and they made it, and this launch happened. And today, the satellite is working beautifully, and we are able to get enough of data. Same thing happened for XPOSAT, X-ray polarimetry satellite, to look at the black holes and look at the accretion of the twin black holes combination, or star black hole combinations, which looks at X-ray, strong X-ray visions. And this is also one of the interesting payload that we launched. Another interesting payload we developed was SpaceX. There are 2 satellites together that was launched and then separated out and docked. So in the development part, I was there, but then after launch, only I retired. But the docking, everything happened post-retirement. Doesn't really matter. Retirement doesn't matter. But the luck happened. And I was very proud to see that it docked successfully many times and the mechanisms worked. Which again paved way for us to configure the Chandrayaan-4 where multiple dockings are going to happen. So this is my journey in ISRO. So I tell you that as chairman, I really enjoyed the 3 years of very intense work, aligning the vision of the Department of Space and ISRO with what the nation is looking at, increasing the spirit of our engagement. That it was really a very successful time. I faced no real failures or issues. primarily. Though there was one failure, though it happened during my SSLV time, that was also solved. GSLV failure was solved. Chandrayaan landing happened. And I could create a vision and action plan for next 25 years. That is something very phenomenal. Very proud of that aspect. But then what I want to tell at this moment is not this. I also developed a 300 people. And during this time, I decided that I am going to do what my bosses did to me. They mentored me to become the chairman at some point in time, or to become a leadership position at some point in time. Or even in that group did not become. And we were selected and then mentored and trained in many, many ways. We were even training at a sort of management at many places in Bangalore and Ahmedabad. We had internal programs where senior people came and talked to us and then helped us to learn various aspects of administration, finance, and technology and procurement, every damn thing that you can think about. And pick people who have a drive to do all of this out of so many, because everybody wants certain roles that you think. So we have to actually select people and then mentor them. This I did, and I did a whole ISRO campaign. 300 people were picked up, and this campaign ran for months together before I retired as chairman. And for that journey, Dr. Radhakrishnan, who came forward and helped me to become the mentor of the whole people, and many others, Scottish Rao who came, and many senior people I invited to join, and they were as evaluators, they were observers to look at it. There are the team members went through, so there are training programs, evaluations, and there is a ranking available to us, which is available to the organization to look at what position they should hold in the future. I think this is a very important role. It was done at senior level as well as mid level, so that our chain of leadership in the organization is never depleted at any point in time. So this is again one interesting one which I did. I'm very happy about that.
Any parting message you want to give, a short one, to close the video? To whoever's watching and dreaming about
There is
space.
never a parting message. It's a journey continuing. The message is that even after my tenure as chairman is over, my work continues. As Vikram Sarabhai professor at ISRO, I also work as a distinguished visiting professor in the Institute of Science. I also handle the role of the honorary chancellor of Chanakya University, advisor to space technology at Andhra government. But more than that, I work with all the startup companies, in space. What means I am a mentor to all of them. If whoever comes, I'm ready to mentor. Mentor means I spend time with them. I work with the young people. I understand their issues, advice, whatever is required. Wherever my knowledge can help in terms of review, technology aspects, I help them. So I'm really busy now in terms of the work and engagement with all these people. And I'm seeing the energy and enthusiasm in the sector, and I make connects to what they require for them to grow. And I'm part of their journey. Very extremely happy to see that India is growing with the young people working in space sector. They are not only working with India, they are also globally connected. And this is also a great opportunity for us. And possibly this journey will take me to many, many more things. I am very sure about it. I am looking forward. Thank you.